The following animation shows the unique Aqualiner process, which is used to rehabilitate drinking water and sewer pipes underground without the need to dig up the road. In this video demonstration, the process is shown lining a short section of broken sewer from manhole to manhole. In practice, the entry and exit points could be up to 200 meters apart. One of the major benefits of the Aqualiner process is that compared to other techniques, the equipment is compact and can fit into a transit van. This is important as it helps to minimize congestion when undertaking work in built-up urban environments. The major capital items include an inversion drum, a thermoplastic composite sock, an air compressor and generator, and a process control system. Access to the broken pipe is gained either through existing manholes or by digging two small access pits. The unprocessed thermoplastic composite lining material and umbilical, which supplies the heat and air for the process, is then winched through the length of the pipe to be repaired. A device known as a pig, which incorporates the patented heater system, is then attached to the umbilical using simple connectors. The umbilical is then connected to the generator and air compressor to supply the required processing conditions for lining the pipe. Once connected, the pig is then positioned inside the thermoplastic sock where it is preheated for approximately 10 minutes. As stipulated by water companies, the pig has been designed with no moving parts. This ensures that all the equipment is sufficiently robust to be used in the most demanding conditions. The heated pig is pushed through the pipe by inflating a rubber tube known as an inversion bag, which is initially spooled inside what is known as an inversion drum or elephant. The inversion bag is sealed to the end of the drum using a Jubilee clip, and the chamber of the inversion drum is internally pressurized up to 3 bar. This large internal pressure forces the rubber tube to expand, and under computer control it is then allowed to unwind out of the drum. The inversion bag is then guided through a series of tubes until it is aligned with the back of the heated pig at the entrance to the pipe. In this way, the extending rubber tube pushes the heated pig through the material at a constant rate. The heated pig melts the plastic sock, which is then pressed against the pipe wall by the same uncoiling inversion bag. Once in contact with the pipe wall, the material is held while it cools down to form a solid structural lining. The following section illustrates how the material is heated and then consolidated against the wall of the pipe. As can be observed, the heated pig is being pushed through the pipe by the extending inversion bag. As it moves, compressed air is fed into the pig, where it is then heated up to 220 degrees C and forced through the thermoplastic composite fabric, causing the plastic to melt. The molten mixture of plastic and glass fibres is then pressed against the wall of the pipe by the inversion bag, where it cools to form a solid homogeneous pipe. The whole process of controlling the compressed air flow, electrical power and inversion bag payout speed is performed by Aqualiner's proprietary process control unit. The same equipment not only controls the time, temperature and pressure characteristics of the process, but for quality assurance purposes records the details of each installation. The whole lining process is continuous, with typical speeds of up to half a meter per minute. Work is ongoing to increase the lining speeds to 1 meter a minute, which would enable contractors to install up to 400 meters in a single working day. Once the pig has completed the run, the power is switched off and the deployment of the rubber inversion bag is stopped. A standard hand-operated disc cutter is then used to trim the end of the pipe. With the pig clear and the end of the pipe trimmed, pressure is maintained for a minimum of 5 minutes to ensure that the whole lining has cooled sufficiently. The pressure is then released, which allows the inversion bag to be wound back into the drum. Manufactured from a high-grade silicone material, the inversion bag is capable of being reused many times. Once the inversion bag has been retracted, a standard cutting pig is sent into the pipe to cut open any side connections. These are easy to locate because the molten thermoplastic composite material is flexible when hot. As such, it balloons into any holes, helping to identify their position. After making all the necessary side openings, an inspection CCTV pig is finally sent through the pipe to check that the new lining has been installed correctly and is ready for service.